RF-based communications are currently the cornerstone of space communications, but the radio and microwave portions of the electromagnetic spectrum are getting close to capacity. So with the reliable infrared laser, similar to the fiber optic cable bringing TV, internet, and phone into your home, NASA is venturing into a new age of high-speed data delivery. Why lasers? Radio frequency and lasers both travel at the speed of light and in the form of a wave, but 10,000 infrared waves can fit into one radio wave, which means you can get more information faster via laser light over the same period of time than you would with RF. The concept of space-based optical communications has been proven in previous low data rate demonstrations. But the Lunar Laser Communications demonstration will introduce a new infrastructure and will have the ability to transfer data 5 times faster than its predecessors. Although short-lived, LLCD will provide an important building block to the next tier of laser communications. So with one eye on the present and the other on the future, NASA is preparing to implement an operational optical communications network. The Laser Communications Relay demonstration is the first step in establishing this infrastructure. Over a 2-year period, LaserCom will leverage the pioneering work of LLCD and other optical communications technology efforts to move another step closer to the ultimate vision of a satellite-to-ground optical network. Essentially, this network would be capable of supporting both deep space missions and near-Earth communication needs. LCRD will expand on the capabilities of the Lunar Laser Communications demo by leveraging commercialized optical communication components and existing operational ground facilities. Our partners at MIT Lincoln Lab are nearing completion of the designs and flight qualifications of the optical module, the PPM and DPSK modem, and the optical module controller. They have recently installed the Lunar LaserCom ground terminal at the White Sands complex in New Mexico to support the LLCD operations. The LLGT will become one of LCRD's ground terminals after some minor modifications, such as installing adaptive optics, data recorders, modems, and other ground support equipment. Once retrofitted, the ground terminal will transmit a beacon and communication data through only one transmitting telescope and receive both the DPSK and PPM modulated optical signals from the spacecraft through only one receiving telescope. The LCRD team at the Jet Propulsion Lab in Pasadena, California, will make similar modifications to the Octal telescope facility on Table Mountain, which will serve as the second LCRD ground station. Together, these ground stations will allow LCRD to demonstrate its real-time optical communications relay capability, as well as characterizing performance and atmospheric effects. Such effects on the DPSK signal is why adaptive optics is needed on both facilities. In keeping with NASA's goal of a cost-effective technology demonstration, NASA Goddard is procuring the commercialized hardware like the optical module, the controller electronics, and the space switching unit. Goddard is also building the modems in-house according to the MIT Lincoln Lab designs, which call for the PPM and DPSK modulations to be built into one modem. In order to utilize existing commercial access to space, Space Systems Loral will host the LaserCom payload on one of its commercial satellites, which is a first for NASA. This highly anticipated launch is scheduled for 2017. Higher volume and lower error rates will enable the next generation of tracking and data relay satellites to evolve into a global network which offers optical services. Future near-Earth and deep space missions will transmit unprecedented amounts of data, as will commercial and military spacecraft. We already know that data handling and transmission needs evolve rapidly, and NASA intends to meet those needs. Before there were smartphones, the idea of streaming HD video to your cell phone was thought to be futuristic and far off. The same could be said about NASA streaming HD content from the surface of Mars. But this could happen in just a few short years. Our communications infrastructure needs to be ready to support tomorrow's demands, and LCRD is the first giant leap in establishing our operational optical communications network. This is no longer a vision, it's a reality.